Friends, welcome again into yet another session of Maths into my YouTube channel, Maths with Mukesh Raj. Hope, friends, you all are good and enjoying this very fine weather outside. And today, into this session of Maths, we will be dealing with the trigonometric identities. We have already seen the trigonometric ratios into our previous sessions, and now we are switching on to the fresh new topic of trigonometric identities. So, what are trigonometric identities exactly mean? Trigonometric identities are something, it's like an equation where we are having trigonometric ratios as a part of this equation, and if we solve for any trigonometric ratio and for a particular angle, this equation stands to be true for all the given or whatever angles we are trying to find it out. So such an equation becomes an identity which can be used into the consecutive formula in the form of formula so as to verify and prove different kinds of trigonometric ratios. So this was the conventional like definition, you can call it, or the process of identifying or understanding a trigonometric ratio. Now, whenever we talk about these identities, which are like the standard formulations which can be used or utilized for the purpose of solving it, there are lots and lots of tons of trigonometric identities which can be used into the trigonometric chapter or trigonometric problem solutions. Let us see a few of them in today's session. And for the purpose of understanding these concepts in a proper way, this entire session of trigonometric ratios will be divided into two sections, part A and part B, where we will be covering the entire trigonometric ratios one after the other. A few of the trigonometric identities, list of trigonometric identities which we are going to look on to today's session. Fine. So the first trigonometric ratios, a couple of trigonometric ratios that which are going to grouped under category of reciprocal, and the first set of trigonometric ratios that are categorized as in the form of reciprocal trigonometric identities, and the second one is the Pythagorean trigonometric identities. So these are the identities. Okay, fine, friends. So if we take the reciprocal, means that we are dividing the trigonometric ratios by 1 and see what is the difference that comes upon, or we are trying to find out the difference after dividing it by 1. So sine theta, if it is divided by 1, okay, reciprocal of sine theta is 1 upon cosec theta. Similarly, if we just reciprocate them in this form, as we have written this, sine theta is equal to 1 upon cosec theta, and once we reciprocate it, reciprocate means if you are interchanging the values of place of the sine and cosec, so it becomes that cosec theta is equal to, correct it, the cosec theta equals 1 upon sine theta. So all the primitive trigonometric ratios, whether it be sine, whether it be cos, and even the tan, all these trigonometric ratios can be represented as in the form of their reciprocal. Okay, sine theta can be written as 1 upon cosec theta. Similarly, moving ahead, we can write cosec theta as 1 upon sine theta. Similarly, cos theta is equal to 1 upon sec theta, and then sec theta can be written as 1 upon cos theta. Tan theta as in the form of 1 upon cot theta, and cot theta as 1 upon tan theta. Since we are dividing it by 1, therefore the name comes out to be the reciprocal trigonometric identities. Similar, the next set of trigonometric identities are Pythagorean trigonometric identities. We know that Pythagorean theorem is used only in the case of a right angle triangle. And we have seen into the very initial stages of this trigonometric session where we proved that trigonometric ratios are the part of a triangle which is always a right angled triangle. That is why here we can use this theorem of Pythagoras theorem with respect to the trigonometric ratios, like sine square a plus sine square b is equal to sine square a plus cos square a is equal to 1, which means this a here stands the value of angle which is either 45 degree, 30 degree or 60 degree. So if we put the same angular value with the square of sine and cos added together, we will land up with a value 1. And remember that this value will be, this trigonometric identity will be applied for all the trigonometric angles, 30 degree, 60 degree and even 45 degree. Similarly, 1 plus tan theta, 1 plus tan theta tan square a will be equal to sec square a. The same trigonometric identity can be written in this form also, like sec square a, or any angular general value, that variable that we can use, sec square a minus 1 will be equal to tan square a. Fine. So this is how these trigonometric identities can be remembered. Before moving ahead with the next trigonometric identities, it is requested to all my dear learners, fresh minds, that you will have to remember, learn by heart these trigonometric identities, and as you solve the problems, you would be able to find out its application into the given problem. Now, the next one is cosec square a is equal to 1 plus cot square a. So these are the two very primitive primary trigonometric identities which are used into the problem solving. The next set of trigonometric ratio identities are associated with, like, uh, trigonometric ratios for the ratio of the trigonometric identity. See, okay, ratio of trigonometric identities. We know that the sine and cos for any angular value is represented in the form of the lengths of a trigonometric of a right angle triangle. But once we find out the value of tan, we want to find out the value of tan and cot. The tan can be found out as in the form of either opposite by the hypotenuse, which is the side of a right angle triangle. But there is another method where we will be using the ratio of the sine and cos, which will again give you the value of tan. That is why it is known as ratio of trigonometric identities. The ratio of the trigonometric ratios gives you the trigonometric identity. That is, tan theta can be written as ratio of sine theta and cos theta. Since we know tan theta is written as 1 upon cot theta, similarly cot theta can be written as 1 upon tan theta. Now, since we are having this cot theta value, we need to find out. So we are taking the reciprocal of the tan value, that is cos theta upon sine theta, and then that is why it is known as ratio of trigonometric identities. The next trigonometric identities, my dear friends, is with respect to the opposite angles. What if you reverse the angle with a negative value or a positive value? Then what difference does it apply on your trigonometric values for the given particular angle? Like, say if we are having a value of sine theta, but this sine theta, the value of angle, say let's say suppose 30 degree. Let's say we are having this angle of 30 degree. For the first one, I am going to explain this. Sine negative theta will be equal to the value of sine negative sine theta. Suppose I am taking the value of 30 degree. So if I write sine negative 30, then in that case it can be directly written as negative sine 30. So both these values can be equated to each other. So this is just to make our calculations more simple and more adaptive as per the given question and situation. Sine negative theta will be equal to negative sine theta. cos negative theta will be equal to cos theta. We can directly write these substituted values into our solution for a given problem. That is why they are known as identities, which can be used directly for our results that we can obtain as a result, as a value of the given question. Similarly, tan negative theta is equal to, so tan negative theta will become negative tan theta, cot negative theta will be equal to negative cot theta, cosec negative theta will be equal to sec theta, and then cosec negative theta will be equal to negative cosec theta. So friends, these are few of the trigonometric ratio identities that we have looked on to this session. Hope this video will find value and add to your studies. Thank you very much for watching this video. Do not forget to like, share and subscribe my channel Maths with Mukesh Raj, where maths is being tried to make a fun for the aspiring young minds of the current generation. Thank you friends once again. Hope to see you very soon into the next video. Thank you very much friends.